Hello! In this video you will learn about the fascinating metals molybdenum and tungsten, their properties, the advantages they offer in different applications, and production and processing at Plansee. My name is Adelhelm. As Business Development Manager, I support new customers to get in touch with our materials for applications related to EUV lithography and semiconductor metrology. Some words about our company. Plansee's headquarters is located in Reute, Austria, a mountain area very close to the famous Castle Neuschwanstein. Founded more than 100 years ago, we employ 3,500 people worldwide and our supply chain is vertically integrated. From ore, powder production, pre-material manufacturing and machining up to assembly in clean rooms and refurbishment, Plansee controls each step and guarantees quality and reliable supply for seamless production at our customers. What are the properties of molybdenum and tungsten? Our metals have a very high melting point, 2620 degrees C for molybdenum and more than 3400 for tungsten. This gives them high temperature strength. However, for high-tech applications, other properties are even more important. First, corrosion resistance against liquid metals like tin used in EUV sources. Good electrical and thermal conductivity. In applications with high power densities, our metals help to remove heat and keep temperatures at acceptable levels. A low coefficient of thermal expansion, CTE. This is a great benefit if you want to reduce dimensional changes related to temperature variation, or bonding of metal to a ceramic material is required. And last but not least, tungsten shows an exceptional high density of 19 grams per cubic centimeter. It can be used for anti-vibrational weights and is the perfect choice for shielding radiation. This means no toxic metal like lead has to be handled. What advantages offer our production route? The Plansee production process is based on powder metallurgy. You can see the complete sequence here. Most important steps are producing metal powders, followed by pressing, sintering at high temperatures, and deformation like hot rolling or forging. By this, our materials show the full density and good mechanical properties. Let me explain you two advantages of our production route. We can easily make alloys or change properties by adapting the sintering and deformation process. First, the alloys. We can add other metal powders and make a powder mixture, which we further process. Let's have a look when adding rhenium to molybdenum. On this graph, the yield strength is depicted depending on the amount of rhenium we add into the powder mixture. You can see how the rhenium content increases the material strength significantly. For the second example, we have a closer look to the sintering and deformation steps. To produce a rod material, we apply forging to densify and elongate a sintering ingot. This process leads to a non-isotropic property. What does this mean? Have a look on the two special directions of a rod. The one in the length direction is called axial and the other, perpendicular to the rod axis, is called radial. The mechanical properties of molybdenum can be totally different in these two directions. On these two graphs, we show the yield strength and the elongation of different molybdenum materials depending on the direction. A regular forged molybdenum rod has almost 400 megapascal yield strength in axial direction, but a very low strength in the radial direction. Similar behavior you can see with elongation on the right side. If we adapt the production process, we can produce a new molybdenum material called Dumomet. It shows a little bit lower yield strength, but it is independent of the direction. For axial and radial, it shows around a little bit more than 300 megapascal. On the right side, with elongation, you can see that Dumomet is exceptionally ductile, both for the axial and radial direction. If we need an application with very high yield strength in axial direction, we can combine forging and addition of oxide particles into molybdenum. This is the dark bar showing data for a forged TZM molybdenum rod. Besides our regular production process, we also work with additive manufacturing, laser powder bed fusion and filament printing, just to name two examples. This allows us to produce complex shaped parts even in large quantities. With this, I want to invite you to our booth at MTC 2024. My colleagues and I are looking forward to meet you.